most electricity is generated at large power stations and then distributed to consumers, such as factories and homes, sometimes over substantial distances. This involves a large and complex network of cables and facilities together known as a power grid. Power transmission. The vast amount of electricity required by industry, businesses, and homes has to be distributed to precisely where it is needed. Power lines both above and below ground transmit the electricity, while transformers, some of which are located in substations, adjust the voltage. A network of sensors ensures that these vital pieces of equipment are working optimally. The transmission of power happens in 6 steps or phases. Step 1. Power station. The generator located in a power station converts kinetic energy into electrical energy. This provides a supply of alternating current electricity typically at 25,000 volts. Step 2. Grid substation. A grid substation uses transformers to increase the voltage, typically to 400,000 volts. The higher the voltage, the less energy is lost as heat from resistance when the electricity travels along power lines. A transformer alters the voltage of electricity through the process of electromagnetic induction. First, alternating current flows through a transformer's primary coil, wound around an iron core. It produces a changing magnetic field, which induces a voltage in a secondary coil. If the secondary coil contains more wire than the primary, the voltage is increased, or stepped up. Less wire results in a voltage decrease, or step down. Step 3. High voltage tower lines. Transmission towers are often made from steel-reinforced aluminum. They are fitted with glass or ceramic insulators to prevent electricity from the power lines traveling down the steel tower to the ground. Transmission towers are usually tall steel and aluminum towers featuring a lattice or tubular frame. They carry power lines at safe heights above ground level and feature insulators to separate the high-voltage cable from the earth tower. Have you ever wondered how can birds perch on power lines? Electricity always flows along the path of least resistance. Birds do not conduct electricity well, so the electricity bypasses them, instead continuing to travel along the power line. Step 4. Direct supply to industry. Some factories with high electricity requirements may take power directly from the high voltage lines. Other factories require a transformer to step the voltage down to approximately 132,000 volts. Step 5. Distribution substation. The high voltage electricity is reduced to a much lower voltage at a substation, which usually includes several transformers. From here, it is supplied to smaller industrial and commercial customers. Step 6. Domestic supply. A network of distribution lines supplies electricity to houses. The final voltage reduction takes place at pole-mounted transformers, before the electricity supply passes into a home's fuse box. Underground cables. To reduce the visual impact and land use of rows of towers and the power lines they support, many electricity supply cables are buried underground. These cables require multiple layers of protection and insulation. The cables are placed in trenches. Individual cables can be up to 0.6 miles long, and extra reinforcement is added to the trenches at the points where the cables are joined. The cables are guarded by concrete covers that prevent accidental cable cutting. Direct buried cables are specialized cables designed to be exposed to soil and moisture underground. The highly conductive wires are protected by 4 outer layers and buried in trenches around 3 feet, or 1 meter deep. And there you have it. That is how electricity travels and allows you to watch great videos like these. Did you learn something new? If you like the content, then please like the video, comment below what you learned, and subscribe. We'll see you in the next video.